All right, let's look at an example together. If you want to try this on your own, you can pause the video and try it first and see how you do. And kind of just use the techniques we saw on the other page and go through the steps and kind of sort through which strategy we're using. So it says a researcher claims that the mean annual consumption of cotton is greater than 1.1 million bales per country. A random sample of 67 countries has a mean annual consumption of 1.0 million bales. Assume the population standard deviation is 4.3 million bales. At alpha is 0.1. Can you support the claim? And they would like us to use a p-value method here. So first thing I'm going to do is I'm going to do the requirement check. So again, is your data random? It does study random. And then is your N at least 30, or is the population? Well, we have here that our N is 67, so we are good. Next thing I'm going to do is get myself set up. So my claim is that the mean annual consumption is greater than 1.1 million bales. So the mean is greater than 1.1, again, million bales. So our mean is greater than 1.1. Now, because this is a greater than sign, it must be the alternative. So our claim in this case is the alternative. The opposite of greater than is less than, and don't forget the null always has equals. So my null will be less than or equal to. And our alpha here is 0.01. Now, the fourth thing I'm going to do here is I do want to have my test statistic. I do need to know am I using a Z or a t-test. Now, if you look up here, we see that it says the population standard deviation is 4.3. Population. So we know what sigma is, right? So sigma is known here. So I'm going to go ahead and I'm going to use my z-test then. Now the X bar is from your sample. So it says the sample mean was 1.0. So 1.0. Don't forget the mu is from your testing setup here. So 1.1. Our sigma is 4.3 and our N was 67. Now I'll let you do this on your calculator. You get about negative 0.19035, or using 2 decimal places, about negative 0.19. Remember, z-scores we typically use 2 decimal places for. For steps 5 and 6, I'm going to just draw a picture. Now, remember here, my alternative hypothesis had a greater than sign, so I must have a right-tailed test here. So my shading is going to be on the right. And we are using a p-value method. So if I'm using a p-value method, then this area here is equal to my p-value, not the alpha. So I do want to be careful there. So this, again, 2 different strategies. P-value as an area that's here is equal to that p-value. So as I was saying, the shaded area is the area on the right in this case, and that is going to represent the p-value. So in the p-value method, the shaded area is the p-value. So what we're going to do is the boundary of the shaded area is actually going to be your test statistic here. Now, our test statistic is actually pretty small. It's a negative number. It is a little unusual to have a negative when you're shading on the right side, but it's not unheard of. So, actually our test statistic is somewhere over here. So when I'm shading on the right, I actually should be shading in a lot more of the area here, like this. But remember, for the p-value method, the boundary of the shading is your test statistic. So that's how that's going to work. Now, you can use Excel here, or you can use table 4 in the text. I'm going to just use table 4 in the text because it's a little bit easier to do in the video. And I'm going to bring that table over. And then what I'm going to do is I'm going to find this value here in the table. All right, so I'm on the negative side here. I'm looking for 0. Let's see, 19 and I have 0.1 is way down here. And then 9 is the first column. So I'm just going to go all the way down to get to 0.19. And I see the value of 0.4247. So that is the value that I'm taking out of the table. All right. Now we do have to be a little bit careful because remember this was a right tail test and the table always gives the area on the left. So it actually gave us this area here. So when I'm finding the area on the right for, again, a right tail test, I'm going to take 1 minus that value. All right, so 1 minus 0.4247, and I have a p-value of 0.5753. And again, if you're using technology, you have a very similar process. So again, watching out for area to the right here with subtracting with 1, and you should also have about the same p-value. Maybe with tech, you may be a little bit off, but it should be very, very close. All right, our next step here is to compare our p-value with our alpha. Our p-value is very, very large here. It's way over the alpha. So we are going to fail to reject the null hypothesis. So going back up to our claim for a second, we're going to fail to reject the null. So that means that we're going to keep the null hypothesis, right? We're not rejecting it. And so the claim is the one that we're not supporting here. So at this point, because we're failing to reject the null, we're basically saying, hey, the null seems fine right now. So because the claim is in the other spot, we're not supporting it in this case. So part 8 is again writing that statement. So here, there really is no evidence to support the claim at the 1% level, right? Our alpha was 1%. So we're not supporting the claim here, which was that the mean was greater than 1.1 million bales on average. All right, and let's do one more example together. So again, this is a great time if you just want to do some practice here and pause the video and see if you can kind of do it on your own or at least start it on your own. It says a fitness magazine advertises that the mean monthly cost of joining a health club is $25. All right, so the mean cost is $25. You want to test this claim, so that's the claim we're testing. You find a random sample of 18 clubs that has a mean monthly cost of $26.25 and a standard deviation of $3.23. We're going to assume the population is normal. Our alpha is 0.10 here. And do we have enough evidence to reject the advertisement's claim? And we're going to use that critical value method. All right, so step 1 is requirement check. So 1 is our data random, and it is. And 2 is your n at least 30, or is the population normal? And again, this is pretty much the standard requirement check for a lot of work with means. There does change if you're testing proportions or something different. So do know that. But for means, this is a pretty standard one. Now our n here is only 18 because we're doing 18 clubs, but it does tell us that the population is normal. So the second part is meets the requirement. We're going to set up our claim and our hypotheses. Our claim here is that the mean cost is $25. So is means equals. So if we fill in our null and our alternative, the null must be going, let me this whole thing in, to the equal sign must be going to the null hypothesis, right? Because it's a regular equal sign. And then the alternative would be the opposite, which in this case is a not equal to sign. And then we also need to note our alpha is 0.10 here. So these 3 steps, again, are consistent when we're hypothesis testing for just one single sample and we're doing it for means. Now, the next thing I'm going to do is I'm going to do the test statistic. So I do need to know here if I have sigma. So if I read through, it tells me that the sample mean cost is 26.25. And again, we're in the same sentence here as the sample. So that standard deviation is not the population, it's the sample one instead. So sigma here is unknown. We don't know what the population standard deviation is. So because it is unknown, we are going to use a t distribution. So our test here is going to be t equals x bar minus mu over s over root n. Our sample mean was 26.25 right there. The mu again is from your hypothesis, which is 25. The S is $3.23, and then our population or our sample size, excuse me, is 18, so square root of 18. And you should get about 1.6418 or about 1.642. And again, this is your test statistic. Now, for t values, we tend to use 3 decimal places rather than 2, but of course you can refer to your problem or your text to see what you should be using. Another thing I do want to note too is remember the alternative hypothesis will tell you the type of test you have. So because I have a not equal to sign, I know I'm doing some sort of two-tailed test here. And we are also using the critical value method. So now this next steps are going to be based on that critical value method instead of the p-value method. So steps 5 and 6, again, for me, I think of like the graphing, the table work, or the technology work, the calculations and things like that. So here, I'm just going to do a quick rough graph. It's two-tailed, so I have some shading here, and I have some shading on this side. What happens here is these are your critical values, right? So these are your critical values. That's what we want to find. So the cutoff is not the test statistic here like it was in the p-value method, they're critical values. And then what happens here is your shading is the alpha. So because I have it on each side, you end up getting the alpha cut in half for our shading. So because our alpha is 0.10, you'd have 0.05 on each side. Now, to find the critical values, we are doing a t-distribution here. One of the easiest ways to do that is to just use table 5 in your text. So again, you can use tech. I encourage you to watch my Excel videos if you want to use more technology. Table 5 is pretty easy to use though, so I tend to like it. And I'm going to bring that over. So a couple things I have to note to use table 5. I need to know, in this case, that it's a two-tailed test. So if it's a left or right tail, that's a one-tailed, but if it's a not equal to sign, we have a two-tailed test. So I need that idea of 2. I do need to know what my total alpha is. So my total alpha we said was 0.10. And I also need to know my degrees of freedom, which is n minus 1. So 18 minus 1 is 17. So I need to use those pieces of information when looking at my table. All right, so here's that table 5 in your text. It's your t-distribution table. Again, because I have a two-tailed test, I'm looking at the column that says 2, or sorry, the row that says 2. And I'm looking for the value of 0.10 because that is my alpha. And then I'm going to go down till 17. So for me, let's see, it's about right here at that 1.740. Now, don't forget that when looking at the picture, I'm just going to make this a little bit bigger here. Because it's a two-tailed, that 1.740 will be on both sides, and you'll make the left side negative. So if you need a left value using this table, you would just use the negative of the number there. So that gives me my rejection region. Okay. And then what I'm going to do is I'm going to figure out, well, where does 1.642 fit? And if I put it on my table here, it would be maybe about right here. It doesn't have to be exact, but I can see that it's definitely not in the rejection region, right? It's not bigger than that 1.74. So in this case, our test, so this is part 7, statistic is not in the rejection region, so we fail to reject the null hypothesis. So remember, we only reject if our p-value is very small, less than the alpha in the other example there, or less than or equal to alpha, or if our test statistic falls in one of these rejection regions. It's not happening here, so we're not going to reject the null hypothesis. So our final piece here is to go back up here and let's think about what's happening. So in this case, our claim was actually the null. We are failing to reject the null hypothesis. So that means we're keeping the null hypothesis. So basically, like, this one is winning here. And that means the other one must be the one that we kind of throw away. You can think of it that way. So we're keeping the null. Well, the null happens to be the claim here then. So then we are definitely not rejecting the claim in this case, right? We're keeping it. So our conclusion here is that there is no evidence to reject the claim at the 10% significance level, just abbreviating there, because our alpha was 0.10. And again, our claim was that the mean was equal to 25. So as of right now, the Fitness Magazine says that the mean monthly cost of joining a health club is $25. And based on our sample of 18, that seems reasonable, right? There's no reason right now for us to reject that claim. So we are leaving the claim as it is, and we're not going to reject it. So I hope these two examples helped a little bit more just to clarify some of the differences in the steps. There's a lot of similarities, right? Steps 1 through 3 for hypothesis testing for means with a single sample like this is all the same. Test 4 is the test statistic, and you just have to be careful, are you using Z's or T's? But otherwise, it's a very similar formula. And then the big thing is the p-value versus critical value method. So that's where steps 5, 6, 7 really alternate, and the idea of the shading changes from the two different strategies. So I think that's one of the hardest parts, is not mixing up what the shading means in each case. So in the p-value case, the shading represents that p-value or the probability or the area. Whereas in the critical value case, that shading is representing the alpha, and it represents the rejection region. So you have, again, a little bit different ideas in those two sections.